Okay, great. Thank you. Thanks, Lucas, for the introduction, and thank you, everybody, for the chance to present to you all today. My name is Mies. I'm an energy systems modeler at Open Energy Transition, or OET. And today I'll be talking about a project that my colleagues and I are working on called Open-TYNDP, which is built on PyPSA. So very quickly, if you don't know who OET are, we are a relatively young global nonprofit. Our goal and mission is to promote and support open, reproducible, and transparent energy systems planning all around the world. And we do this through a number of ways, including building and maintaining software, developing data sets and tools, and providing capacity building and training, et cetera. And I will also give some context on what Open-TYNDP is. And perhaps before going into Open-TYNDP, it would be useful to just discuss what is the TYNDP part. And the TYNDP stands for 10-Year Network Development Plan. It is a series of studies and reports developed and published by the ENTSOs, ENTSO-E, and ENTSO-G. It usually runs in 2-year cycles and is made up of 3 steps. The first is the scenario steps, which consist of the scenario building or SB process, in which the ENTSOs develop scenarios which define possible various futures for the European energy system. The system needs step looks at identifying infrastructure gaps at a system scale. And finally, the project assessment consists of the cost benefit analysis, or CBA process, in which each transmission and storage project included in the TYNDP is assessed one by one to determine their costs and their benefits or their added value to the network. Um, the TYNDP process is important because one, it's just a critical part of the European planning process, and two, it plays an important part in shaping grid investment priorities. And what I mean by that is that some of the steps here in the TYNDP process, such as the CBA, are used to determine if an infrastructure project, such as a transmission line or a storage project, can be eligible for certain special statuses, such as project of common interest or project of mutual interest. If you're not familiar with these statuses, they are basically very helpful for energy developers to gain priority funding and to get their projects approved or permitted, et cetera. So the TYNDP is, in conclusion, not just important to the TSOs and SOs, but also to project developers as well. Within our project, Open-TYNDP, we focus only on the scenario building and the cost benefit analysis components of the TYNDP process. So those are the parts that I'll be talking about for the rest of the presentation. So what is Open-TYNDP? As the name implies, it is an open version of the TYNDP process. In the last few years, both ENTSO-E and ENTSO-G have expressed their commitment to the transparency, inclusiveness, and efficiency in the TYNDP process. So our goal at OET is to, with Open-TYNDP, is to support ENTSO-E in this commitment by exploring and building an open source implementation of the TYNDP methodology, which we do in coordination with ENTSO-E. So Open-TYNDP itself is based off of PyPSA-Eur. It is a soft fork of PyPSA-Eur. And like I mentioned, our scope of our project is focused on scenario building and cost benefit analysis. Our aim is to build a reproducible, transparent workflow utilizing these aspects of PyPSA-Eur that with a single command will take raw input data, run the model, and generate visualized and benchmark outcomes. In terms of timeline, we kicked off the project around the end of 2024, and just last month we released version 0.7 of Open-TYNDP, which includes a benchmarking of our scenario building results against the 2024 TYNDP national trend scenario, as well as a flexible and fast implementation of the CBA as well. We have mainly focused our efforts on the 2024 TYNDP release so far, but as part of the next steps at OET, we are preparing to explore expanding the Open-TYNDP framework and workflow for future cycles such as 2026 and 2028. Here is a graphical overview of what the scenario building workflow looks like within TYNDP. I don't know if my mouse is visible or not. So very broadly speaking, there is a set of public input data that includes things like demand profiles, capacities, etc. Within the current TYNDP process, there is a usually proprietary model that is used to take these input data, run the studies, etc., and produce a set of publicly released output data that includes the output files from the market models, as well as a report. What we are doing with an Open-TYNDP is we're building an open source alternative using PyPSA to the market model that can be run alongside the market model. And we use the same public input data, process it, run our model, and release our outcomes, which we also benchmark against the TYNDP release 2024 outcomes as well. I will also add that in using our workflow, we are replacing a lot of the PyPSA Europe data because we're using instead the public input data that TYNDP releases. And we also have built our own data processing pipelines to read in this data and use it for our model. And now that I've described what Open-TYNDP is, I'll just quickly go over what you can actually do with it. So obviously, it being a open source model, you can run it as it's been designed, but one could also test different scenarios and benchmark their own outcomes against the ENTSO-E outcomes as well. And obviously, we want to promote collaboration and to continue to benefit from the community-driven developments of open source communities, etc. I will be remiss if I don't give a shout out to my colleagues at OET who keep this project running and going, as well as ENTSO-E for providing their valuable knowledge and input to the project as well. Now I'll quickly go over some of the outcomes from our model or from our latest release, etc. We have been able to successfully benchmark our outcomes at both an aggregated level at the EU27 level, as well as at the country and nodal level. And headline thought is that our results quite closely match the 2024 TYNDP national trends results. And we do this for both the power sector as well as the hydrogen sector. And additionally, in addition to what is published on our website, which I will share later, we also have a Zenodo archive of detailed benchmarks, including ones like this here, which is at the country level, looking at a lot of more specific benchmarks. But again, our results, for the most part, quite closely match the results published in the TYNDP 2024 outputs. So I mentioned the website, and it is live, it's online, and we have there a description of our methodology, as well as a lot of our results. So some of the plots you've seen here, and as well as many more interactive plots, are all available on the website. So please do check it out, and feel free to reach out to us if you have any feedback. And we also have an abundance of different resources and links, including our code base, documentation, as well as workshop notebooks that you should feel free to check out and look at as well. And for all the Windows users out there, we also have developed a Windows-specific installer guide. So that is available to you also. Yeah, so to close off, with Open-TYNDP so far, we have been able to successfully benchmark our scenario building results to the TYNDP 2024 results, as well as implement a CBA methodology that is quite fast and flexible. And we're still working on improving the CBA every day to hopefully eventually benchmark that as well. And for potential next steps, we are exploring extending the Open-TYNDP workflow to support future cycles. And we are looking forward to welcoming further continued exchange with TSOs and further training and capacity building as well. So that's it. Thank you very much. And yeah, please reach out if you have any questions and thoughts.
Thanks a lot. There's one question by Tom already, that the validation looks great, but where do you think is the difference still coming from?
So that's a great question, Tom. So actually on our website, we detail where differences could be coming from for specific plots and benchmarking. So if you're interested in any specifics, they're on there. They're usually related to specific sectoral representation and things like that are discrepancies between our PyPSA model as well as the TYNDP representation.
Can I jump in with the follow-up question?
Go for it.
Yeah, there's also this identification of the system needs, which is also super interesting to be able to reproduce openly. Do you have any plans for that, or is there a specific reason why that wasn't tackled?
I'm not aware of any plans or any specific reason why that was not including the scope, but as far as I know, we don't have any specific plans for that, but it would be interesting as well, I think.
Thank you.
Can I ask a question?
Yeah.
Yeah, TSOs, along with RGI, and the European Commission are developing a pact for engagement, but they have no idea about this kind of analysis. Do you see it useful for public outreach?
Can you clarify, do you mean public outreach to the general public or to TSOs and to specifically?
No, this is to do with the general public to increase public acceptance.
Yeah, I mean, we hope so. We hope that by having something that is, open and not behind closed doors, that members of the public who are doing maybe research or analyses on European energy systems would find this tool useful. And we are also actively, trying to do this ourselves because we have training materials and workshop materials that are open as well, so that people can learn how to use this tool and play around with it and validate it themselves. So we do think that the fact that this is something that anybody can look at and access could be useful in public engagement and reaching out to the public about this kind of work.